Hello, I am Lennert. I'm a PhD at the KU Leuven, and I'm very glad to be presenting recent work that we did about the parallelization of the inference of neural probabilistic logic programming, specifically by applying tensorization wherever possible. So neural probabilistic logic programming deals with structures, as you can see right here, these probabilistic circuits that combine the probabilistic logic with neural networks. The problem is that depending on the query, specifically the arguments of the query, the probabilistic circuits that you obtain can be very different in structure. For example, if we look at the addition of two images to the number 1, or we look to the addition of two images to the number 0, the subsequent circuits that you extract from these queries are very different, as you can see right here. And this is problematic because if we want to parallelize things, if we want to parallelize the computation of queries, then we need to have the same structure. Now, our solution to this is to, very generally, construct a query that is valid for every instantiation of the variables that you put into them. In this case, all of them are tensor variables. So what we do is we exploit the fact that we can write down symbolic tensors and that we can do computations on these symbolic tensors to write down a more general query that is valid for a wider range of full instantiations, and then we can still extract a completely valid probabilistic circuit which is larger but completely valid for all the instantiations of the tensor variables, as you can see on the bottom right. This circuit is valid, we can parallelize this, and that means that we get a speed up in inference and learning. And we can also apply some further optimizations, but if you want to have more details, then I will be very glad to talk to you at my poster.